parts were done by Gregor Bonnet and Benedict Paffen. So also Marco Schuber was involved in this investigation. A short overview. First, a short introduction. For those of you who don't know what a SCADA system is, a short structure of what is a SCADA system, and then I will present you the device we actually investigated. Then we have the TwinCAT software, which is the proprietary software from Beckhoff to manage the systems. And then Beckhoff also used a proprietary protocol. It's called ADS, Automation Device Specification. Then I show how our security investigation was done, and then the possible attacks to this against this device. And then last but not least, some advisory for suppliers who use this PLC. Okay. Why do we start this? This PLC, this device, is an older device. It's not very new, but I will show you that's relevant for the complete SCADA security issues. So first of all, the globalization of the business and the growing number of decentralized companies leads to the part that the industrial control systems have to be networked, beziehungsweise the internet enabled. So in the ICS, which is the industrial control system, the essential part of this ICS is the SCADA system, which stands for Supervisory Control and Data Acquisition. In the last month or years, there are known attacks against these devices, and the number of attacks is growing because the PLCs work in the direction of our normal or usual IT infrastructure. So the hackers can use their well-known tools to attack these devices. So first of all, there is a different understanding of security between the normal IT security people and the SCADA engineers. I think you know about the IT security things, which are confidentiality in the first time. Confidentiality, integrity, and availability of the data. That's completely different in the SCADA systems. The most important thing is the availability. If the machines are not working, you don't earn any money. So the availability is the most important part of all. Then comes integrity and confidentiality, even if it's an issue at all. The security of the SCADA devices, they were engineered with no security in mind. There are older systems. Remember maybe Windows 95. There are no security built in. Also, they were at the start not engineered with the possibility to have remote connections to them. Many of them are 15 years and older, and the manufacturer don't like to exchange all the devices, never change a running system, so it costs money and the machines are not working. New devices have built-in security, but we met a representative from the manufacturer, from the vendor Beckhoff, which is a German company. They said, okay, we have new PLCs out there, but 90% are older systems with no security or with very little security. So the structure of the complete SCADA and IT in the factory is shown here. We start at the very top with an enterprise resource planning system. That's the normal servers you know maybe in a normal factory. Then coming the manufacturing execution systems. These are servers, mostly for the managers who want to have data from the production process and so on. And then we step over to the more mechanical part of the whole system, which are the supervisory control and data acquisition systems. These are the managing systems for the controllers, the PLCs, or RTU, which means a remote terminal unit. These are devices where mainly the same like PLCs, but they have mostly more remote connection possibilities. And at least there are the sensors and actuators in the field. The communication between the SCADA systems and the PLCs are mostly special protocols. Maybe you know there are some of them. For example, Beckhoff uses ADS, Siemens uses NetBus, and so on. There are different protocols used. So here we have, I tried to show you the complete system in a factory, so the well-known business part of it, the business network with the workstations and the servers and the printers connected to a switch. There may be a firewall, mostly there is a firewall which disconnected us from or secured us from the internet. And then there is also connected the devices in the SCADA headquarters. There may be some application servers which are counting data and so on from the production process. There is the engineering workstation. The engineering workstation is the workstation for the engineer who develop the programs for the PLCs, and they can transmit, they can develop them on these machines, and they can transmit them to the PLCs. And then we have on the bottom right the remote stations with a manufacturing process. There are the PLCs, and the PLCs are connected with the field protocols, with the sensors and actuators and so on. The communication between the SCADA headquarter and the remote station is done over a communication network, which might be an internet or a Wi-Fi or a satellite or something like that. Okay. I hope you've got an idea how this complete system looks like. So here is a system we investigated. It's a PLC. It's originally an embedded PC. Had a dual-core 8-core processor, 1 gigabyte of RAM, and a flashing card is serving as a persistent memory. Also, the operating system is saved on this card. It's the box is at this size, and you see on the top left the Ethernet connectors, which are the connectors to the SCADA headquarters. We have some USB connector there, a DVI connector, so you can connect a monitor, and you have on the bottom left the possible connector to the field bus. Here in this picture, it's an older one for a serial communication RS-232. There may be also a Profi bus or a CAN open bus, so there can be a connector like Ethernet. Yeah? The very good thing with EtherCat, and Beckhoff is the developer of EtherCat, which is meanwhile an open source protocol, everyone can use it. The EtherCat is based on Ethernet, so you can use all usual material you use for normal Ethernet. So you can use your normal switches, your connectors, your network interface cards. All these devices work together with EtherCat. So like a normal operating system, the operating system on this device is Windows CE 6.0. And I showed you the USB connectors. You can connect a keyboard or a mouse. And the system is able to get a password. You can configure a password for an administrator. So if you start a complete system, it looks like a normal, maybe a little bit like a normal PC. You have the possible login screen there. And if you don't have any keyboard connected, there's a virtual keyboard on the bottom left, so you can use it. Or even if you don't have any keyboard connected. So the TwinCAT devices, TwinCAT is the management software for the SCADA system and the PLCs. The TwinCAT devices are, they have a unique net ID. And this net ID you need if you want to communicate to the device. The net ID is an enhancement of the IP address. You see that here. It's the first 4 numbers are the usual IP address, and then there are 2 numbers which, together with the IP address, are building the net ID. And you have to know this net ID if you want to communicate to this device. To have the communication, and because all the devices must know each other, you have to build up a routing table. You must establish a route to each device. So here it's something like a routing table in a router. You have the net ID, the transport address, which is the address you will see here, the last point, ADS is transported over TCP and UDP. So the transport address is the IP address to which the packet will be delivered, and you need the device name. This is the protocol, the proprietary protocol from Beckhoff, Automation Device Specification. It's used by the TwinCAT server system and also with a running DLL on the embedded PC on the PLC. It's optimized for throughput. It's encapsulated in TCP IP. So it's an older protocol. You can also encapsulate it in some serial connections, some serial protocols. There is no encryption, but you see it, there is a possible authorization. So you can configure a password for the admin. To manage the PLC CX5020, you can use some tools from the Windows CE system. The most used tools are, for example, CX configuration tool. You can configure an FTP server or a VPN connection with this tool. There's also a network and dial-up connection tool. You can configure the IP address, or if you have a modem or something like that, you can configure the dial-up connection. And last but not least, we have a password tool, so you can configure a password on this PLC. When we start our investigation, and you cannot, those of you who visited the two-day training from Justin the last 2 days, they know already it's hard to pen test a PLC which is actually working in the complete system. So because they are not very hardened, the systems crash very fast. So we did our investigation. I will show you the setup a little bit later with a separated PLC. And we started with an Nmap scan to see which ports are open and which services are behind these ports. We found 16 open ports. This is a not configured PLC, as it, no configuration at all. All default things are on the PLC. So we found some well-known ports. You see port 23, all hackers are here. You found port 80. So, and some other ports you know already maybe, but there are some ports you didn't know. For example, the port 987 or 5120 and the 2 ports in the 48,000. So I will speak a little bit later on it about this. The 2 ports, 48898 and 48899, are the maintenance ports. They are mentioned on the website of Beckhoff, and they advise the suppliers of this PLC to open the ports on the firewall. Very good idea, I will show you. So these are the unknown ports. So first of all, we started the plaintext protocol Telnet. It's enabled by default. It remembers a little bit of the early Windows systems where no security was built in, but if you start the system, it must work. So that's the same thing here. Telnet, they often use Telnet, so Telnet is enabled by default. And if you start a connection to the PLC, you get a greeting phrase, which is welcome to Windows CE, Telnet service on CX ABCDEF. The last thing is the host name of the device, and the ABCDEF is the MAC address in ASCII characters. So they also showed you we have a password tool. You can configure a password. They have a default username and password on it. So the default username is a very unguessable username webguest, and the password is a really awesome password 1. So if you know that, you have to know that the people who are working with these devices are not IT people, no IP staff, no even IP security people. So they feel be hindered by this kind of always putting in some password or that, yeah? So last but not least, there is a Windows system on it. I already mentioned this. It is a single user system. What means if you have an account, it's always an administrator account. So if you have one account on the system, and every account you create on the system has already full administration privileges. And if you have one account, it's very easy to use a built-in function, CX add user. You can create new accounts as much as you like. So also there is a web server running by default. If you connect to the index file, you get a message, welcome to Beckhoff CE device. Then there is a special administration interface, and the web server supports virtual directories, and one of these virtual directories is the administration interface. To connect to the web server, you have to use the IP address, port 5120 and /config. That's one of the ports we found with the nmet scan. So as we saw that, we were interested in how many devices we maybe find on the internet, and it's easy to search these devices. First, we searched for open port 23, and then we searched for the greeting phase, and then we searched for the port 80, connecting it to it, and then searching for welcome to Beckhoff CE. We found some very interesting devices. Roundabout, we used ZMap to do the search. Maybe you know it. It's a tool with which you can scan the complete internet. We didn't do that. We just running the ZMap tool about 3 hours or 4 hours, and we found over 100 devices from Beckhoff, and we identified them. Some popular was a PLC at the airport of Moscow. We don't know the function because we're a little bit angry. Mr. Putin would visit us, so we stopped that. But we also found a pump in a swimming bath in Stockholm, which was responsible for mixing water and chlor. So that are some of the devices we found. Okay. Then the web server, as I told you, supports virtual directory, and one of the amazing thing here is the remote admin virtual directory. It's the Microsoft Windows CE remote management tool, and this was configured, not configured by default, but it was activated. So, and it also was not documented in Beckhoff's manual. What can you do with this connection? So, if you visited it first, you can put in a password and you have full control. So, because it's not mentioned in Beckhoff's manual, mostly this feature is not disabled. If you have the connection to the PLC, you can configure network, time, file, print server settings, and so on. So the second thing is CE Remote Display. That's a remote desktop service for Windows CE. It listens on port TCP 987. You saw it in the Nmap scan. Here you need a password to connect to the device. The connection setup is transmitted in plain text. So if you are connected to the local area network, there's a man-in-the-middle attack of up-spoofing possible. And if you are able to authenticate, you have also full control over the PLC. So the SCADA Service, I want to talk a little bit about the ADS protocol. It's a proprietary protocol, and the TwinCAT System Manager uses this protocol, and the TwinCAT System Manager controls all PLCs in the field. There are different functions which are able to do with the System Manager. For example, you can discover PLCs, and I will show you what the result of this discovery will be. And you can transmit afterwards, after you have connected, you can transmit programs so you can influence the manufacturing process. So this is our test setup. As I told you, EtherCat is able to use the usual Ethernet or Ethernet equipment. So we have the engineering workstation connected to a switch, and this is connected to the different EtherCat devices. The blue arrows are the TCP/IP traffic, and the yellow arrows are the EtherCat traffic. So we connected our investigation PC also to this switch. This was our test setup. So first of all, I told you the TwinCAT System Manager is able to search for PLCs. So it's working like this. The engineering workstation is sending a search. In this picture, you see a router. It even could be a switch. If it is a switch, you can send a broadcast, a UDP broadcast. If it's not a switch, if it's a router, you must know the IP address of the embedded PC, of the PLC, and you are able to look for every IP address to search for PLCs. Yeah? So you have to scan the complete IP range for that subnet. So the search devices use a broadcast, so it's built up like this. It starts with a start sequence. It's always the same with ADS. Then there is ADS parameter range. It's not important for this topic. But then we have the net ID. I told you, you have to know the net ID of the target system to communicate with it. So here's the net ID, which can be, is from our attack PC. So it can be completely random. Only the fourth part must have the IP address of the local area network. The complete thing works over port 10,000. So this packet we are sending to search for PLCs, and the response from the PLC is, it starts also with a start sequence, a parameter range, but then we can get the ADS net ID from the PLC. So now we are able to connect, maybe if we have credentials, connect to the PLC. We know the net ID of the PLC. It's the same port, 10,000, and we got also the username, the host name of the PLC and the TwinCAT version. So if you have the net ID, you can create an ADS route which you need to communicate with the PLC. In the packet is built up like this, also starting with an ADS packet header, then the ADS net ID which we got from the searching packet, the engineering workstation host name, then you need a username and a password, and then the IP address of the sending station. There is no encryption, so the username and password is in plain text. If you can sniff such a packet, you don't need any attack. You already have the username and password, but if not, you see it's in plain text, so it was easy to re-engineer this packet. And if you like to, if you want to connect to a PLC, you can see here what's the response of this packet, of this building route packet. So if the password is correct, no, if it's not correct, it's the first example. If it's not correct, you will get an error code which is not 0. And if it is correct, you get an error code which is 0. So no problem to have brute force attack. Okay. We did this. Oh, okay, here's a complete process, complete message flow. Maybe you can see it. Yeah. It's the same if you have found a password username pair. You can connect to the PLC. You can programs. You can see commands. The first two parts are sent over UDP, and after that we start using TCP. Okay, possible attacks. From this, what we found with the machine was, first of all, the virtual directory remote admin. That was often not deactivated, so it was very easy to connect to the machine, set a password, and you have a full connection to it. With this connection, you can even create a VPN account. So after that, if the VPN ports are open in the firewall, you can remotely from outside the factory connect to the PLC. The second thing is, I showed you the brute force attack. So the machine is not blocking after you are trying too often a false password, a wrong password. So brute force attack on port 48899 is very easy. The PLC answers very fast. Nice to know. And there are multiple connections in parallel, possible in parallel, and we wrote a Python script to test that, and we got about 8,000 passwords per second. And after we found the password, we have full control over the ports, also over the ports 987 and 48899. The third possible attack was the PLC has the opportunity to have VPN connection to it, but the VPN connection is, sorry, PPTP, with MS-SHEP version 2, which is vulnerable since some time. We only did a proof of concept. We tested that, and you have to do a man in the middle. And then after you sniffing the connection establishment, we did this with Wireshark. You got some packets, and there is a challenge and a response packet, and the values on the right side you need to know to have a brute force or a dictionary attack against the machine. So after that, we did a brute force attack with asleep. It's a Python script. Here we have the screen with the running script. There is a start of the script with all the parameters we found in the Wireshark documentation, and then we have found the password. So it's also not a good idea to use PPTP as a VPN connection from outside to the PLC. The last thing is you saw the USB ports. You can not only connect keyboard or a mouse to this connectors, but also an adapter for Wi-Fi. And there is a built-in driver in the PLC for adapters with the RT2501 chip. And if you connect the adapter, it's almost automatically connected. And we found some names which could be names of wireless LANs. So in the registry of the Windows CE60, we hope that this would be the point that if we connect the adapter, it will automatically connect to access point with this net, but it doesn't. So you have to connect the adapter, and afterwards you must choose a special WLAN to connect to. So if you have this, you have your own channel to manage the PLC. Maybe you can bypass an infrastructure firewall with this Wi-Fi connector. So what are our advisories for the suppliers? First of all, disable remote admin virtual directory. It's a horrible mistake to build this inside this PLC. Disable Telnet, always a good advice. Limit the number of ADS packets per second, so there is no brute force attack possible. Deliver the device with strong passwords. We saw that often the one was the password as we investigated the machine in the field. Delete the WLAN drivers on the PLC and use an alternative VPN technology. So thanks for your attention. Okay. So